Hey y'all, this video is pretty nerdy. It's getting into the lower level details of how your stuff actually runs and is organized in .NET. Here's what we're going to cover. This stuff might seem a little complex, but it's really not that bad. Today we're going to demystify assemblies. You've seen them. They're those DLL and EXE files show up when you compile your app. I'll show you what they really are and why they matter. We'll also cover AppDomains, which used to be a big deal in the old .NET framework. They're mostly gone now, but understanding them helps you appreciate modern .NET better. Then we'll see how modern .NET handles things differently with AssemblyLoadContext. I'll be honest here, I don't think about this stuff all that often, but I'm really glad that I'm familiar with it for those times when a weird error shows up, or you're running into strange debugging issues, or you're reading someone's old .NET framework code. Let's start with assemblies. Every time you build your project, you're creating an assembly. An assembly is just your compiled C# code packaged up into a file. When you hit build, the compiler takes your .cs files and creates an assembly. In modern .NET, assemblies are usually DLL files, even if they're console apps. You'll sometimes notice that there's an EXE that gets graded for you, and that's often just a tiny launcher that loads the real DLL. That launcher EXE pretty much only works on Windows, so, well, they're not that helpful. Assemblies don't just have your code. They have metadata about that code. What types are in the assembly? What methods are on those types? What other assemblies they need and reference? All that stuff is in there. A good way to think about the assembly metadata is that it's like a table of contents for the assembly. Think of an assembly as the smallest chunk of code you can deploy. You can't deploy half a DLL. It's all or nothing. One assembly, one file. Let me show you what actually goes into an assembly when you build your code. Every class, struct, interface, enum, they all get compiled and packed into the assembly. Doesn't matter how many files you have, they all end up in one DLL. Your C# doesn't compile to machine code. Yeah, that's kind of a surprise for a lot of people who are new to the .NET world. So I'll say it again, your C# doesn't actually compile to machine code. Instead, it actually compiles to something called intermediate language, which is also known as IL. It's like a universal assembly language for .NET that gets converted to real machine code when your program runs. This has a lot to do with allowing .NET to run across multiple operating systems. The assembly knows about every type, every method, every property. This confuses everyone. Why does .NET Core create DLLs instead of EXEs like the old days? An EXE only runs on Windows, but a DLL can be run by the .NET command on any operating system, Windows, Linux, Mac. That's the magic of cross-platform .NET. When you do get an EXE in .NET Core, it's usually tiny, like 150K. All it does is find the .NET runtime and tell it to load your actual DLL. It's a glorified shortcut. The DLL next to that EXE, that's where your actual code lives. The EXE is just there so Windows users can double-click something. Linux and Mac don't even need it. When you type .NET run, it's not looking for an EXE. It's looking for that DLL file. In a way, the .NET command is the X. That's the part that actually runs your application. Your assembly probably needs other assemblies to work. Here's how that works. When your code uses a list, or HTTP client, or some other type, if you didn't write it, then that code is almost definitely in some other assembly. Therefore, your assembly has a list of all the other assemblies it needs to run. So what about NuGet packages? What are they? Well, when you install a NuGet package, you're really just downloading someone else's assemblies. They're wrapped up in a package with some additional NuGet-specific metadata, but under the surface, it's just assemblies. Put another way, NuGet is basically a DLL delivery service, with version management wrapped around it. And those assemblies might need other assemblies, which need others, and those in turn probably need yet some other assemblies. It's a tree of dependencies. Those dependencies can get insanely complex, and luckily, .NET figures it all out for you at build time. Now let's talk about AppDomains. This is something that used to be huge in .NET Framework, but is mostly faded out of view in .NET Core. AppDomains were like having multiple mini-programs inside one program. Each AppDomain was isolated from the others, couldn't mess with their memory. This was a .NET Framework thing, and it only worked on Windows. When Microsoft made .NET cross-platform, AppDomains had to go because they were too tied to Windows. The main use was loading and unloading assemblies without restarting your program. Like hot swapping parts while the engine is running. Super cool, but complex. And to be honest, while that sounds super cool, it wasn't really actually all that useful for your day-to-day production code. That is, unless you were doing some kind of plugin architecture, people used AppDomains for plugin systems. You'd load a plugin DLL, and if it misbehaved, you could unload the whole AppDomain. The plugin couldn't crash your main app. It was kind of a neat trick, but then again, this also added complexity. Here's what AppDomain code looked like. This doesn't work anymore, but it's good to know the history. Each AppDomain had its own copy of static variables, its own memory space. A crash in one AppDomain didn't affect the others. It was like having multiple programs in one. You could run untrusted code in a separate AppDomain with restricted permissions, like a sandbox. If the code tried something naughty, the AppDomain boundary stopped it. When you unloaded an AppDomain, all its memory was freed. Perfect for long-running server applications that needed to load and unload components without memory leaks. So what happened to AppDomains? Why did Microsoft remove them? AppDomains relied on Windows-specific features. To make .NET run on Linux and Mac, they had to go. Cross-platform was more important than AppDomain features. AppDomains were expensive. Crossing AppDomain boundaries was slow, like making a network call but in memory. Modern .NET is all about speed. And like I've mentioned a few times before already, most developers never used AppDomains, or at least never actually used AppDomains properly. They were complex, easy to misuse, and the benefits weren't worth it for 99% of applications. Need isolation? Use separate processes or containers. Need plugins? Use AssemblyLoadContext. Need security? Use OS-level sandboxing. Better tools for each job. If you do need to load and unload assemblies in modern .NET, here's how you do it. AssemblyLoadContext is much simpler than AppDomains. Less isolation, but also less overhead. It's the right trade-off for most scenarios. Unlike AppDomains, this works everywhere. Windows, Linux, Mac, even mobile platforms. Write once, run anywhere, including your plugin system. But here's the truth. You probably won't need this. It's mostly for framework authors and people building plugin systems. Most apps just load assemblies and leave them loaded. So when do you actually need to think about assemblies in your day-to-day coding? When two NuGet packages want different versions of the same assembly. This is the dreaded DLL hell. You'll see errors about could not load assembly version X. Your app runs fine on your machine but crashes on the server with file not found exception. Usually means an assembly didn't get deployed. Check your publish output. When you publish your app, you're really just copying assemblies around. Understanding this helps you troubleshoot deployment issues. If you're doing advanced stuff with reflection, looking at types at runtime, you're actually interrogating assembly metadata, but that's advanced territory. Here are some practical tips about assemblies that will actually help you. That bin folder in your project, that's where all your assemblies live after building. Your DLL plus all the DLLs it needs. It's your app's universe. Weird errors? Try cleaning and rebuilding. Sometimes old assemblies stick around in the bin folder, causing confusion. Delete the bin and OBJ folders if you have to. Fun fact, the assembly version and NuGet package version can be different. The package might be 2.1.0, but the DLL inside might be 2.0.0.0. This causes so much confusion. Those assemblies in ref folders, they're fake, just the API surface without implementation. The real assemblies are in lib or runtimes. Don't deploy the ref ones. Let's wrap up what we learned about assemblies and AppDomains. Every project becomes an assembly, usually a DLL. That's your code plus metadata about your code, all packaged up. Modern .NET uses DLLs instead of EXEs because DLLs work everywhere. The .NET command runs them on any operating system. AppDomains were a .NET framework thing. They're gone in modern .NET, and honestly, good riddance. They were more trouble than they were worth. For 99% of your coding, assemblies just work. Build your project, reference your packages, and let .NET handle the details. Focus on writing great code. Next up, we're diving into something way more practical, collections. Yay, lists, arrays, dictionaries, all the data structures for managing groups of objects that you'll use every single day.